An ancient star seen zooming through space at 600 kilometers per second. Most of the stars in the Milky Way tread sedate, orderly orbital measures through the galactic center, but that's not the case for everything. Every now and again, a maverick is caught breaking ranks, whizzing along at speeds that will eventually see it punted clean out into the intergalactic space. These hypervelocity stars are extremely rare. We're talking about stars here, not planets, but we've just spotted a peculiar special example, the star named CWISE for short. Not only exceeds the galactic escape velocity around 600 kilometers, that's 373 miles per second. It's a very rare type of tiny, ancient, main sequence star called an L subdwarf, which happens also to be one of the oldest in the Milky Way galaxy, our galaxy. First spotted by citizen scientists combing through telescope data for signs of the mysterious Planet 9 or Planet X. This CWISE is one of just a handful of hypervelocity stars identified in the Milky Way, and although far from the farthest we've seen, it represents something of a challenge to astronomers, namely, how did it get so breathtakingly fast? The discovery was announced in the 244th meeting of the American Astronomical Society, with its paper recently submitted to the Astrophysical Journal Letters. There are a number of possible explanations for the star's velocity. Researchers explored three of them: ejecting following an explosion, scattering by a black hole, or accretion from the Milky Way satellite. Now, at first, the first is expulsion from a binary system that includes a white dwarf star, the remnant core left behind when a sun-like star runs out of hydrogen, ejects most of its outer material and dies, and enters its afterlife. Ultra-dense white dwarfs shine hotly with residual heat rather than fusion, and can be a bit unstable if they have a binary companion. If the two stars are in a close orbit, the white dwarf can steal material from the companion star. The problem is that the white dwarf has an upper mass limit. If it gains just a bit of mass, it can maintain its existence throughout repeated eruptions known as nova. However, if it gains too much mass, it will explode in a type 1A supernova that completely obliterates the white dwarf. In this kind of supernova, the white dwarf is completely destroyed, so its companion is released and flies off at whatever orbital speed it was originally moving, plus a little bit of a kick from the supernova explosion as well, says astrophysicist Adam Burgasser, University of California, San Diego. Our calculations show this scenario works. However, the white dwarf is not there anymore, and the remnants of the explosion, which likely happened several million years ago, have already dissipated, so we don't have definite proof that this is the origin. The second possibility, as a many-bodied interaction that becomes unstable and yeets one of the objects across the galaxy, there are environments within the Milky Way that make these interactions more likely, namely globular clusters, dense globs which can contain millions of stars, thought to contain swarms of black holes at the center. Globular clusters have a higher than usual concentration of black hole binary pairs. When a star encounters a black hole binary, the complex dynamics of the three-body interaction can toss the star right out of the global cluster, says astrophysicist Kyle Krimmer of Caltech, shortly to join UC San Diego. This too is plausible, but tracing the star's trajectory backwards has not yet allowed the researchers to identify a specific globular cluster as its starting point. And the third position is not from the Milky Way at all, but one of the many satellite dwarf galaxies orbiting it. A 2017 study examined the provenance of hypervelocity stars, found an extragalactic origin plausible, and the researchers' calculations show that it's feasible for this as well. All three options remain on the table. The best way to figure it out will be to examine the chemical composition of the star in greater detail. So if this star was a companion of a white dwarf, The supernova could have left trace elements that polluted the L subdwarf's atmosphere. Conversely, globular clusters contain stars that all have similar compositional properties, so it may be possible to link the star to a home population that way. And if neither of those pan out, we may need to look at the Milky Way satellites to determine whether this tiny dim star is a stranger from outside the galaxy, just winking howdy as it passes through. The discovery was presented at the 224th meeting of the American Astronomical Society. I just hope this thing doesn't come towards us. This is by Michelle Starr in the Science Alert. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.